Hello students, today we will start chapter 5.1. We're first talking about the slope of a curve. So in junior form, you have learned the slope of a straight line. So at the left hand side, you can see we have A and B, and then the slope of AB, okay, is easy, right? It is y2 minus y1, and then over x2 minus x1. So means the vertical increment over the horizontal increment. Okay, so in the right hand side, I will also like to introduce one term to you, which is tangent. So this tangent is not that trigonometric ratio, sine cosine tangent. Better see, it's referred to a line. So you may see here we have a curve y equals to fx. Okay, and then L is a line which touch the curve at one point, which is A. So in this case, we will say L is the tangent to the curve at the point A. So it means the tangent, okay, it can be represented to a trigonometric ratio, but it can also represent a line which touch the curve at only one point. So now, okay, we go to some more details. So here we have a point, okay, in this graph we have a point A and P. In different graph we also have the point A and P. So let's look at this first. So here, if this point A, this is the x coordinate, which is A, right? And this curve is y to the fx, so you have, when you put the x into the y to the fx, then you have the fa is y. So AFA is the coordinate of point A. And if this is A plus delta x, delta x is just a number, you can imagine. Why we use delta x is because it is the change of x. So here it is A plus delta x. Similarly, we will get A plus delta x here, and also f A plus delta x as the y. So in this situation, we get the slope of AP, which is the y1 minus y2 over x1 minus x2. Okay, and then as a result, we get this. Okay. And now let's go back to these three graphs. Okay, in the first graph, we see the horizontal distance between A and P is 2 units. So actually, the delta x of this case is 2. So you can imagine if P moving, okay, towards A along the curve, then you may have the second case, 1.2 units. So you get delta x is 1.2 here actually. So it keep on approaching, then in the third case, you may come up with A and P are very close to each other, right? So in this case, what is delta x? You can imagine delta x is a very small number, so we treat it as tends to 0. And here, you may observe, we have a line L here, right? So this L is actually the tangent to the curve. Okay, then what is the slope of this L? Okay, AP, we just mentioned, the slope of AP is y bracket, okay, A plus delta x minus FA over delta x. So in the third case, actually delta x is tends to 0. Then we come up with this one. The slope of the tangent L to the curve is the slope when delta x tends to 0 and this limit. Okay, so here actually we defined the slope of the tangent L as the slope of the curve y equals to fx at the point. It means the slope, this L, the slope of this L, we define it as the slope of the curve at this point. So we come up with this one, a very important theorem. The slope of tangent to the curve at x equal to a. Actually, it is equal to the slope of the curve at x equal to a. It means the slope of the tangent is equal to the slope of the curve at the point, and which is equal to this limit we just mentioned before. And here you have two remarks for you. The first, this method is called the first principle. In some questions, they require you to use first principle to find this slope. So you need to remember this formula. And the second, this expression actually is equal to this too. So you can write this as the slope, or this is what we call f prime, a, and this is what we call dy dx when x equals to a. We'll talk about this more in the next part. Well, now, let's go to one question. Find the slope of the tangent to the curve y equal to fx at x equal to 3. So first of all, we can write the slope. Maybe we can first let fx equals to the function. Then we find what we need, the slope of the tangent at x equals to 3. Actually here you can also write f prime 3, or you can write dy dx when x equals to 3. They are the same actually. But we basically usually we follow the questions, right? So we write in this way, the slope of the tangent at x equal to 3. So by the formula we just learned, it is limit delta x tends to 0, f. And now x is 3, right? So it is 3 plus delta x minus f3. And then we get over delta x. Then f3 plus delta x, we just make use of the function. So we get 3 plus delta x whole square. That's 3 square. Delta x. So just do some calculations. So finally, we get 6 is the answer. Okay, so today it's just as a start of this chapter. So we will end here, and we'll